I want to start this video off by talking about the male reproductive anatomy and the male reproductive physiology. And this is a general overview. It's very quick, it's very kind of down to the brass tacks. And all that I want to talk about now is, kind of some of the common structures. You have your penis here. And for those of you who didn't know that, you're in trouble. And then the scrotum. And I just want to make a point about the scrotum is that the scrotum, it maintains a temperature of 3 degrees Celsius lower than that of the normal the normal internal body temperature, what you're going to have up here. So it's kind of like, think of it like the ears of a jackrabbit or of an elephant, how they're really this thick, loose, skin that enables it to kind of have a lot of, as air passes through it, it's going to help cool it off. That's one of the ways that it is able to maintain that low blood temperature. Now, what I want to look at here is this picture does a really good job of demonstrating it. You can see these arterialized blood running down here, but wrapped around it is this pampiform venous plexus. That as this arterialized blood runs down here, it's going to be cooled by this venous blood that's wrapped around it, and that's that's a very unique way of how we can maintain body temperature or 3 degrees Celsius lower than that of what is normally, even in very hot temperatures. Also, they can have these dartos and cremaster muscles can contract, and these scrotum can become taut, so to say, where it comes up closer to the body. It's closer to the higher temperatures, and this is of course in cold circumstances. I think a lot of guys understand that, and that's how things work. Now we're going to move on to the testicles, or the testes, whatever you would like to call them. And there's various parts, as you can see here, and this is a great book. The pictures really labels it well. But you have these little seminiferous tubules. Every one of these little, they kind of look like spaghetti type things here. These are the seminiferous tubules, or the sperm factories. And right here, this little end is called the rete testis, kind of like reticulum, endoplasmic reticulum. This is the rete testis. Rete testis. And then from here, so a generalized course of the sperm is made in the seminiferous tubules. The cilia, you're going to take it to the rete testis, and then from there it's going to be at the head of the epididymis down to the body, then at the tail of the epididymis, and then from the tail it's going to travel up through a structure known as changing the page. So the vas deferens. And this is just a bunch of smooth muscle tissue that the sperm is going to travel up through, and in a vasectomy we're going to cut that, and it's going to travel up through into these, to the ampulla of the ductus deferens. You don't really need to know that, and to the ejaculatory duct here. But this is the seminal vesicles. This is your prostate. These are your bulbourethral glands and your ducts. This is your urethra here. The darker blue colored. This is the corpus spongiosum, which is a small percentage of it, and this, I guess, a lighter blue would be called the corpus cavernosa. These are both just erectile tissue filled with a lot of blood sinusoids, and so that's all I really wanted to provide a visual representation for everything. But now let's move on to some of the more, I guess you could say, the physiology behind what we're going to talk about today. So, talked about the male, the penis, scrotum, sees all this stuff, and I want to talk about how we're not like women. Women have from 7th month in utero, they have made all of the eggs they're going to make, whereas men, we were going to be making sperm till the day that we die. That's the visual representation there. So we're always making sperm, but constantly. They're not as precious as the ovum are. And so what we're first going to talk about is there's these seminiferous tubules, or the sperm factories. And they're these little, coiled up tube things right here, and these green little tree cell things looking here, these are called Sertoli cells, or nurse cells, named after the Italian medical student who discovered them. And they do, amongst a myriad of things, they form the blood testicle barrier in these tight junctions here, as I've drawn in between every single individual cell. And what this does is this forms the blood testicle barrier, because you got to think, unlike in females, where they're born with as many eggs as they're going to make, males we don't even start making sperm till we hit puberty at the age of 11 or 12 or however. And since our immune system was developed at about 6 years of age, once we hit puberty, if our our bloodstream were to enter into this area, they would see the sperm as a foreign cell. They would attack it, and the male would become sterile, and that would obviously not provide what we needed. So the Sertoli cells provide the blood-brain, or I'm sorry, it's similar to the blood-brain barrier, but the blood-testicular barrier. And I also want to think of it is a lipid-soluble barrier. So when you get in the subject of like chronic alcoholics who drink a lot of alcohol on a very highly frequent basis, they're going to have their testicles are going to atrophy, and they'll have gynecomastia. And a part of that is because alcohol is lipid soluble, and it does cross the blood-brain barrier. It also crosses the blood-testicular barrier, which is way more important than the blood-brain barrier. And then these Sertoli cells here are also going to secrete something called Mullerian inhibiting factor. And basically, what you're doing is whenever you're a fetus in utero, or whatever we talk about, you have these little soon to be these Mullerian ducts are going to become the uterus and the oviducts. And so if we were to secrete Mullerian inhibiting factor, that's not going to happen. What's going to happen is the Wolffian ducts, which makes you think, wolves, manly Wolffian ducts. They're going to become the epididymis and the vas deferens. And another thing that the Sertoli cells are going to release a lot of other hormones as well, but they're also going to support sperm development. So they're this umbilical cord type thing that we'll talk about that later, I promise. But another thing inside of your seminiferous tubules, you have, and this is not something that was mentioned, are the Leydig cells, which these Leydig cells secrete androgens, particularly testosterone, into the interstitial fluid. And that's why this picture here is the interstitial fluid, which is the buff bodybuilder, and then the Leydig cells is the trainer injecting it with hormones. Because the Leydig cells release androgens and testosterone into the interstitial fluid, where it can be picked up and carried about through the bloodstream and perform the various amount of functions that it needs to do. And I guess we'll see while we're going on the... Okay, so as we were talking about earlier, your guys are going to produce 400 million sperm per day. Women in their entire lifetime will ovulate 480 eggs. We produce 400 million sperm per day. With each time we ejaculate, with each ejaculation, 100 to 200 million sperm cells. So yes, we make a lot of sperm in a day, but we also can lose a lot of sperm in a day. And so what's going on inside of these seminiferous tubules is and I like to think of them as the seminiferous tubules, if you could, is spermatogenesis. Which they contain telomerase because they're increased longevity. But anyways, the generation of sperm, and what we have here is there's two types of spermatogonia, and I don't know if I wrote that down or not, but that's the word that we call for the mother cells of sperm. And so there's two types. There's type A, and then there's type B. Yeah, type A and type B spermatogonia, mother cells. And what happens is and let's refute back to say that this is a picture of our seminiferous tubules. I know it's a bit more of a rough drawing than what previously would have been expected, but as we start off with these A mother cells, these A spermatogonia, they are undergoing mitosis, producing more of the A type A mother cells, because if we just all went straight to meiosis, we would run out of cells very, very quickly. So we undergo mitosis in type A cells, but in type B cells, we undergo meiosis. So we go from a diploid nuclei to the haploid nuclei. And as we're going through here, so there's meiosis. As we get closer to the center of the seminiferous tubules, they begin to develop flagella along their bodies and beginning to develop the slogging off a lot of excess cytoplasm. So as they move towards there, and so whenever they release into the epididymis, that's the course that they'll take, and they'll learn how to swim, quotation marks, from there. So how do we go from this picture right here of a spermatid, is this round, cellular-like structure, to this picture of a sperm that is this little missile, looks like something from the Matrix type? Well, what happens is, what we have to do to get from here to here is we have to lose a lot of this excess cytosol. And along with that, we're going to lose a lot of organelles too. Remember when we talked about how these Sertoli cells could be these umbilical cord-like structures as well. So as they're carrying it through here to here in the Sertoli cells, undergoing mitosis and becoming from spermatid to sperm, it's going to phagocytize. The solar cell is going to phagocytize a lot of that excess cytosol that we have here. And as it does that, it's going to lose a lot of organelles. And so in order for it to stay alive, in order for it to have a life support system, it's going to have to replace the work for the lost organelles. So as it's going from the basal end to the center end, the Sertoli cells are phagocytizing a lot of that excess cytosol and providing it with a life support system for the organelles that it's lost. So, and now I want us to make a clear point that what moves it from these seminiferous tubules, what moves us from these seminiferous tubules to the rete testis to the epididymis is mostly cilia and a little bit of myoid cells, muscle contraction, but mostly just cilia, taking in things from the efferent tubules to the rete testis and then to the epididymis. And so this final result here of this sperm, this is what the sperms look like when they're in the center of the seminiferous tubules. Is this? Let me look closely here. Is a nucleus with an acrosome around it. And what is this acrosome? Is a hydrolytic enzyme. What do we know about hydrolytic enzymes? Think about lysosomes. Lysosomes are hydrolytic enzymes. Where do they come from? From the Golgi bodies. And what these do is they're gonna break into that first wall of the first wall surrounding the egg cell. And so I have this picture of people with a bat string ram breaking into it, shame on Goya, stay on my wall. And so, and that's the function that it performs. And it's going to, from whenever it degrades, the nucleus is going to be able to enter the cell. And it's just really just the nucleus that enters the egg cell. The nucleus and obviously these centrioles of this basal body, because if we have a flagella, we have to have a base to it. We have a basal body of centrioles, and this is going to become the centrosome of the zygote as well. And we arranged these flagella in a 9x2 pattern